Okay, so this is a continuation of using partial fractions to take antiderivatives, and this video is more of just a practice, because once you did the other part of it, you do need to watch that video first. If you haven't watched that one yet, definitely watch that first. But if you haven't watched that one yet, watch that, because once we get to the point where we need to on these problems, the last step is actually pretty easy. So if I see a problem like this, now when I see one of these, usually, just so you know, usually they will tell you have to use partial fractions. But a couple of things that give it away that let us know that we're trying to find the antiderivative and we're going to have to use partial fractions instead of another method that we've talked about is the power on bottom is 1 bigger than the power on top as far as the degree goes of the polynomials. If that's the case, then we're pretty much good to go, and we just start factoring the bottom as best we can. So in this case, I've got 5x minus 3 on the bottom, or on the top. On the bottom, that factors down to x minus 3 times x plus 1. Now remember, what we're doing here is we're just trying to change this to something that I can take the antiderivative of. So I know that I'm going to have a times x minus 3 plus b over x plus 1. Now what I'm going to do is I'm just going to, like we talked about previously, we're going to get that common denominator. So I've got a times x plus 1 plus b times x minus 3. So I've got those two things. Those look good right there. And then honestly, you've just got x minus 3 times x plus 1 on the bottom. I'm not going to write that anymore. So I'm going to have ax plus a plus bx minus 3b. Then we combine our terms together that have x's in them. So I'm going to have a plus b. And again, I'm going through this quickly because we did quite a few of these in the example, so you shouldn't worry about it too much. Then what I've got is that it needs to be equal to 5x minus 3. Once I have that, I just go a plus b is equal to 5, and then a minus 3b is equal to negative 3. We choose one letter to get by itself in one of them. Let's get the a by itself in the top one, so a is equal to 5 minus b. So I've got 5 minus b minus 3b, plugging it into the other equation, gives us negative 3. So I've got 5 minus 4b is equal to negative 3. I minus the 5 over, so I get negative 4b is equal to negative 8. So b is equal to positive 2. Once I find that, I take that and I plug it back in to find a. So a is equal to 5 minus 2, which is equal to 3. What I know now is I can rewrite this as a is 3 over x minus 3 plus 2 over x plus 1. Now this is super easy to take the antiderivative of. The antiderivative of 3 over x minus 3 is just 3 times the ln of x minus 3 plus the antiderivative of 2 over x plus 1 is 2 times the ln of the absolute value of x plus 1. Then we have our plus c on the end, and that is our answer. Most of those steps are pretty easy. There's just a lot of them that we have to do in order to get that correct answer on a problem like this. So just be aware that that is another thing that you need to remember for the AP exam. Okay, let's try one more just to make sure we've got it down. Okay, I'm going to factor this. I've got 3x plus 11. I notice that the power on the bottom, the degree on the bottom is 1 bigger than the degree on the top. So I've got x minus 3, x plus 2. So over here, when we do our partial fractions, and again, I know sometimes the question pops up, we talked about this previously, but does it matter which one you put on, what letter you put on top of what linear factor? And it really doesn't. Like, you could put the b and the a could switch and it wouldn't be that big of a deal. So I got a times x plus 2 plus b times x minus 3. And again, I'm just kind of walking through this. There's nothing tricky going on here, just using the process that we've talked about before. Distributing the a in, distributing the b in, so I get that. So now I've got a plus b times x as I factor that x out of both of those, or a, yeah, no, whoops, that's not 2x, that's 2a, that's what was throwing me off, sorry. 2a right there. A plus b times x plus 2a minus 3b, and we know that that has to equal 3x plus 11. What that means is that a plus b has to equal 3, and 2a minus 3b has to equal 11. A little monotonous here. Let's get through it. So I get the a by itself in the first one. Doesn't matter what letter we get by itself as long as we isolate it correctly, which I almost didn't right there. Plug that in. I get 2 times 3 minus b minus 3b is equal to 11. I distribute the 2 in, so I get 6 minus 2b minus 3b is equal to 11. So I've got negative 5b is equal to 5. So b is equal to negative 1. So I know b is equal to negative 1. I plug that into my equation where a is 3 minus negative 1 gives us 4. So what I have here is 4 over x minus 3 plus negative 1 over x plus 2. And we're taking the antiderivative of that. Sometimes, so you're aware, sometimes, I think this happened in some of the examples, you do get fractions on the top, like 3/2 or 2/3 or something like that. It doesn't change how we take the antiderivative. That constant still just stays right there, and you get the same thing. It doesn't matter that it's a fraction. Okay, so there's what we've got right there. And if this were a definite integral, like from 0 to 2 or something like that, we would just plug those two numbers in, and we could find those very easily. That is our answer to our antiderivative. Again, hopefully that makes sense. Nothing overly difficult about doing these problems as long as you understand the process of using partial fractions. If you have any questions, please let me know.